geo, if you know about it. So, and these days all interconnections are provided via your optical fiber instead of your general coaxial fibers, right? Okay. So this was like your real life why we need it. Okay. And for longer distance communication as well, this is preferred as compared to others, right? But of course, it is I mean expensive one. So these days everything is like wireless. It doesn't even require any more fibers or cables at all. So at first there is some prerequisites that we'll discuss, and the ones which are written over here, that's like you need vector algebra, rectangular cylindrical systems, and field theory, like elementary optics. So I would say the important ones are the last two, that is your field theory and your elementary optics. That means you should have basic idea about what is reflection, refraction, what is total internal reflection. I am pretty sure you have studied all of them in your 12th, probably in your physics. So I expect you to know the basic Snell's law, then what is critical angle, and all this. Oh, okay, we'll discuss about what is your acceptance, your NA, etc. That is fine if you do not know, but I expect you to know what is reflection, refraction, and rest of the things. Okay. So there is a basic knowledge that is expected from you. And next is what will be the course outcomes. That means at the end of the course, what you should be aware of or what you should have thorough knowledge about. That is, what is a fiber type? Okay, what is a fiber type, and what an evaluation of the parameters and analyzing the number of modes associated with it. So the first set of lectures will be related to this one. Just a minute. Okay, I guess we need couple of lectures, because see, if you do not understand this part properly, I mean, first you have to know what are the parameters. Okay, the first few class will dedicate to parameters, then like your numerical aperture, your acceptance angle, then what your critical angle, etc., etc. Okay, so the parameters will be first discussed, and after that the types of fibers. Okay, your types of fibers, that is your step index and your gridded index. Then based on this you'll have like what are the different modes associated with it, like whether it is a single mode, whether it is a multi-mode, right? So you have here your step index fiber, here you have your gridded index fiber, and depending on your modes you have your single mode and you have your multi-mode. So all of them, I think it will take some good amount of time, and I would be a little thorough about it. So it will take some time. So please bear with me, and of course we'll have a lot of problems. Also, don't think it's a complete theoretical subject. No, it's not. And you'll definitely have some problems alongside, and we'll practice them. And regarding your next, so this is your model one mostly. Okay, then we'll have your what are the different kind of sources. So as you know, when you talk of optics, your optical communication, this is actually the devices. We'll basically discuss about the devices and what do you say, the basic operation, and not in depth about the communication thing, right? Because we have another subject for that, that is optical communication. So many of you might be thinking like opto means if I know optical basics, I know everything. No, it's not correct at all, because you are studying optical, optoelectronics devices and instrumentation. There is another subject that is fiber optics components and devices. Then you have optical communication. Then you have fiber optic instrumentation. So these are all completely different, quite the same fundamental, but yeah, different aspects. Okay, so the as you know, your communication has always like three parts: a transmitter, a channel, and a receiver. So whatever you'll be studying is your the what do you say, the basic part of it, that is the transmitter being the sources, then you have the channel being the optical fiber, which we'll be studying first actually, and then we'll discuss the detector, which is associated with the receiver side. So you will talk totally, but not exactly the communication part, how it happens, right? And then you will measure the physical parameters using your sensors. So this subject has got your sensor part. So there are like so many sensors which are discussed over here thoroughly. So that will come in your final module. Okay, some part we'll be discussing in the class, some part I'll giving you as a task, and we'll have a cooperative way of communicating, and we'll try to finish it off, right? And then at last you have to be able to analyze a given fiber optic sensor, right? So your total complete syllabus has got 3 modules. That is your the first one dealing with your wave optics, as I told you. You will see like how your light transmits through a slab, then how through your different cylindrical waveguides, then your step index, graded index, the modes in step index, graded index, single mode, multi-mode fibers, and then at last what are the various sort of losses and dispersion characteristics associated with the fibers. That constitutes in your model 1. Then we'll go to module 2, and I guess you will enjoy module 1, but you will enjoy more in your module 2 because you'll come across the various optical components, that is your LED and laser, right? So as you guys know, what I think you might be having little, knowledge about what is LED, what is a laser, which is more often used, why often used, right? So you see, whatever we are surrounded with, the interesting part of these subjects like your electromagnetics, your optics, is that you're surrounded by a few things and you're studying about that itself, right? So you'll study about LED, then laser, and then these are the types. So briefly, we'll just discuss briefly about this in your class. Then we'll focus more on this thing, that is your detectors. There are 2 type of detectors. This I should be actually small, so it's my mistake. It should be P, I, and N. The reason being, this is P junction. This is P type semiconductor, N type semiconductor. There's an intrinsic layer in between, so it is not capital I, it will be small I. And this is your avalanche photodiode. So there are 2 type of detectors, right? So this part is your kind of, you can say, the channel part, okay, and the channel being optical. So we'll discuss about the channel over here, and your module 2 will be your sources. This part is your sources, right? Sources means your transmitter part, and this is your receiver part, that is your detectors, right? And after that, this single optical fiber, of course your communication cannot happen through a single optical fiber. You need multiple optical fibers to be connected to each other, and then the power will be transmitted through it, right? So that is this. Again, this is related to your channel. So this is your channel coupling. Okay, and then at last you will have the instrumentation part of the subject, that is what are the modulation techniques, that is your intensity, polarization, interference, etc., etc. And then you will have the sensing techniques mentioned over here, okay, various sensors will be discussed, okay. And the most important one is this OTDR and OFDR, which are most widely used. Okay, these are also used, but actually the kind of an assembly of these sensors you will find in OTDR and OFDR. Like as you can see, this T and this is F. So T is your time based and F is your frequency based. Okay, so we will discuss about this in detail in your towards the end of your classes. The book, actually it's already clearly mentioned in your syllabus that which portion from which book to be studied. So you need not worry. I know you do not possess access to your books, the physical books, because there is no access to the library. I get it. And I do not demand you to buy books. Okay, I understand the condition. But do not worry at all, because I will keep, because I have books with me. So I'll take the scan copy each. I have actually already taken scan copy. So some portions which are left out, I'll be taking scan copy. I'll be providing you all the notes, but that does not mean you won't listen in the class. Okay, So I expect you to pay 100% your attention in the class, because I'll be providing notes at the end of finishing it. So do not think I'll give notes from the day one. That's not going to happen. You have to take down notes as it used to take in your class. Okay. So at least like in a shortcut manner, you have to do it. And at the end of finishing a topic, only you'll be provided with the notes. Okay. So the books are written over here. I would want you to see here. So you can see here, I guess Aruna ma'am is taking your section A class, and this book is written by Aruna ma'am. And trust me, if at all you are interested in having a higher degree in this field, I would suggest you to go through these books, the first, second, and the third one. Okay, so your coupler, etc., you have to go through this book, which is actually not mentioned over above. So the coupler portion, etc., will be taken from this book, and some part of the detector as well. Actually, it is given pretty good in this book, so I'll be taking this as well, and also this book, that is your RP Khare. Okay. And the initial portions, that is your model 1, is completely from ma'am's book. You would not believe, but this book has got so much in it. I mean, what can I say? There is all derivation of all the equations in detail. Ma'am had taken such long time, years together to write this book. Okay, and she is kind of the epitome for your optical communication. I think no one knows better than her, as far as I know, or the people I have met. Okay, so there are multiple problems where I was stuck, and she has even helped me out and helped many of them. So this book is sufficient enough for your what exactly is optical fiber, what the different type of optical fibers, except there are few printing mistakes. Okay, so that I'll tell you definitely. But beside that, this book is really great. Okay. So this is all about the syllabus of your optoelectronics devices and instrumentation. So if you have any doubt, please ask me. And there's one more thing. Since this is an online platform, and I do not want it to be a one-way communication only from me, but also when there is like a flow, and if you are not able to get me, then you can stop me and ask me again. Not an issue. But please, I would request you to cooperate with me and not really nag in between to ask certain doubts, which you have to be a little patient. If I'm going to reach a point, okay, that whatever doubt you're asking, probably I might be speaking about it a little later. So please keep in mind that at the end of the class, I'll definitely ask you whether you have any reservation, doubts, and we will spend time for that. Or even like a class one day, we'll just keep so that you can ask as much doubt as you can. But I request, do not nag me in between, okay, while taking the class. And if it's that important that you're unable to understand further, then you can definitely stop. I have no problem with it. Okay. But if I have told you something and again repeatedly that goes on, it becomes a little difficult. You can stay after the class and I can clear it, or on some other time we can do it. Okay, because we are in a class of around 60 students, so I hope you understand that. Okay, so if you have any doubt in the syllabus or the books part, anything, please you can ask me now. Else we'll just start with the first lecture. Also, one more thing, if I'm going with the flow, you can do one more thing, that is write in the chat box. If there is some doubt, if you have some doubt, then please you can write in the chat box itself, because once I hear a beep sound, I'll definitely stop and then I'll go through it. Okay. So if you have Shubha Lakshmi, do you have anything to say? You sent something in the chat box. Shubhalakshmi, are you there?
No, ma'am.
Okay, so that was by mistake. Right, so we'll move to the first lecture then. So this is nothing but introduction, like the initial portions of the fiber optics. So as I told you, I expect you to know what is reflection, refraction, then scattering, interference, diffraction, okay, and the basics of semiconductors, of course, and a little bit more about what is wavelength, what is frequency, and what is velocity of light. Sorry, not a light. What is velocity of light? And beside that, of course, what is critical angle, angle of incidence, what is angle of reflection, what is angle of refraction, etc. So here we'll discuss about why fiber optic communication is preferred over others, and then what are the optical components, the basic laws, acceptance angle, numerical aperture, etc., etc. So the reason being why your optical fiber communication is preferred as compared, especially for a good transmission of information. Okay. Actually, for longer distance, earlier it was used, but then there were some difficulties faced. That is, since again it is a wire connection and you need cables, and this is not exactly like any other coaxial cable. It doesn't happen like that. So that's the reason why, when you connect, for example, how do I say it? For example, yes, straws. If you have straws with you, right? I ask you to connect one straw, like one end of the straw to another end of the straw. So you need to melt it properly and then stick it together, isn't it? But sometimes what happens, sometimes it gets like one gets more melted and it doesn't properly fit, correct? So in the similar manner, it happens with your cables as well. So if it does not fit properly, like the core and cladding, etc., which I'll be talking right now, if they do not, if they're not aligned with each other, then definitely, there will be an issue. So there wouldn't be a proper transmission of information. Okay. So you can see over here, I'll be sending you this file. Don't worry. So this is a frequency allocation as per the application, right? So as a always say as a engineer of electronics engineer, I expect you to know these things because mostly in interviews, especially if you're going for MTech in your IITs, then definitely be sure if you have applied in the EC department or any department which is related to communication, you will be 100% you'll be facing this question. Okay, there is a various frequency ranges for different bands and the sort of application which are associated with each of them. Okay. So it's mentioned over here. So we have a transmitter, a channel, and a receiver, which we'll be discussing. And yes, it's a non-electrical form at the transmitter, which is later converted into an electrical form at the receiver side. That is in case of your optical communication. Okay. So do not forget that optical communication, the passing signal is nothing but a light. Okay, it is nothing but light, right? So why optical communication is preferred? Because it provides less error, less attenuation, that is losing information. That's less chances. Then it is small size, absolutely small size. It has got lightweight in a manner you can't even imagine. And then it is it's immune to your electromagnetic noise. Yes, it has got better bandwidth, high data rate, no crosstalk, and no physical electrical connection between transmitter. Actually, there is no physical connection between transmitter and receiver because there is a channel in between. Okay. So this is how your optical fiber looks like. Please do not think it looks exactly like this. It is nothing but a fiber of this manner, right? So it's something like this. Okay. So it is just shown like outside thing. So the innermost layer is called as core, then the next layer is called as your cladding, and then the outer layer is called as buffer coating, or sometimes it's also called as jacket. Okay. Or it is also called as jacket. means, I guess someone has asked a question, what is the meaning of no crosstalk? See, there is a chance of interference. For example, if you remember in your earlier days, even now, I shouldn't even say earlier days, even now it happens at times that when you call a person, then someone else actually talks instead of the person you have actually called. But that is again like a crosstalk. It's like instead of see, this is the communication that you're talking of is nothing but there is like there is person one here, there is person two. A channel is formed between these two so they can talk, isn't it? But let's say there is another person three and you connected over here. So there is a crosstalk over here. Okay, so there is like a cross connection, a crosstalk over here, and this is a sort of interference. Okay, which arises if there is not a proper communication, right? So the chances of crosstalk in optical fiber is lesser as compared to your general fibers. That is your coaxial fibers. It's much lesser. Okay, and that's the reason why it is more often used for your basic communication process these days. And it's replacing actually your coaxial cables gradually. But the exact reason why it is not replaced all the places is the high cost of it, right? It requires little high maintenance and it requires high cost. That's the reason why it has not replaced coaxial cables in all the places, right? I hope I answered the question. Now, there's one more, and I guess this must be also told to you in your communication engineering, if I remember correctly, about this interference and all must have been covered in your communication. What was that? Basics of communication. I don't know whether this is that. I guess it was there in the previous semester or the semester before that. Your basics of communication. You just can go through it once more for your own clarification. Okay, so you have your core, cladding, and a jacket, or you can call as a buffer coating. So the most important part is the core and the cladding, and the buffer coating is nothing but a protection that it gives a protection to the cladding layer. Okay, and the most important layer is the core and the cladding layer, right? So whatever diagrams I will do in future, keep in mind it has got only core and cladding. I do not put the buffer coating every time I show a picture, right? Yes, so the core is made of a glass. It is made of glass, and your cladding is made of dielectric material. Okay, and the refractive index of cladding is, so let me just write here once and for all so that later you do not get confused. The refractive index of core is N1 and the refractive index of cladding will be given as N2. Okay, and your N2 is less than N1. So you know when N2 will be less than N1, so definitely there will be reflection. Okay, so that is what we need. We do not need refraction. We need reflection, but this is no ideal case. This is what is supposed to happen ideally, but in your practical life, of course, there wouldn't be an ideal case. There will be partly some refraction which occurs and which may result in losing your signal. That is in a minimal amount. Okay, and we'll see. Gradually, you will see all of that. When we discuss about the various losses in your fibers, you will come to know, you will be aware about all those things. Okay, so for the time being, just keep in mind that the refractive index of cladding is less than the refractive index of the core, and hence it provides the facility for reflection of the light that is back to the fiber itself. So when you have a fiber, so this is your core and this is your cladding. So the light doesn't go like this, so it has to reflect back. Then again from here, this is again your cladding side, right? So it will again reflect back, then reflect, then reflect. So in this way, it will travel through your channel. Okay. So the buffer coating is nothing but it protects your core. Okay. So the most important layer are your core and cladding. Just to confirm you once again. And here this is a basic optical laws and what exactly is your reflection, what is exactly your refraction. When I say the refractive index, okay, that is your RI, that is your N, which is represented as N. You know it is represented by C by your V, okay, and V is represented as the velocity of the signal in your dielectric or in non-conductive method, which is written over here, and you know speed of light, that is 2 into the power 8 meters per second. That's the representation of your refractive index. I'm not going deep into this. You guys already know about it. Okay, and what is exactly your reflection and what is your Snell's law? Everything is written over here. Okay, so I'm not discussing this. I would definitely instruct you, not request you, but instruct you to please read this before the next class. That is the basic optical law. This is again another part of the basic optical law, keeping in mind your critical angle. So we know that the critical angle is the angle when your refractive angle becomes your 90 degree. Okay, so it is nothing but your theta c is nothing but your sine inverse of n2 by n1. I know many students remember sine inverse of n2 by n1, n2 by n1, but they forget what is n2, what is n1. So n2 is this medium refractive index and n1 is this medium refractive index. So that you have to keep in your mind. Okay, it's my sincere request that please keep in your mind, right? So when so this is your theta, yes. So the angle at which you know your refraction angle becomes like greater than your critical angle, the complete angle. So now there will be like total internal reflection. And remember, the optical fibers, they work on the principle of total internal reflection. Please keep in mind, this is a question that many a times it's being asked. I don't know why people just say like it works on refraction. God knows why they say that. Okay? If it works on refraction, that then it will create losses. There wouldn't be any transmission of signal at all, right? Okay, so this is your how your light propagates. It's written in detail, same as your reflection thing. Now, next thing that is your acceptance angle and then your numerical aperture. Okay, so as you know that to satisfy the total internal reflection, the angle of incidence should be greater than your critical angle. Okay, so so theta a is the angle, the maximum angle beyond which the total internal reflection isn't possible. Okay, so that is the maximum acceptance of the signal. So that is a maximum critical angle, and that angle is called as the acceptance angle. And the accumulating capacity of a fiber is called as numerical aperture. As you can see, the term aperture comes from the lens. Okay, and we know like the maximum accommodating thing is called as your aperture, right? So that is in your optical fiber, it is called as your numerical aperture, which is given as n0 sine theta a, theta a being the acceptance angle. Okay. Again, there is a relation which is formed over here. Okay, derivation is carried out. You can go through the derivation. So this is the one you have to keep in mind. Okay, that is your numerical aperture. There are actually number of first one is this. Okay, so it depends what are the parameters that are provided to you, right? If your refractive index of your air is given to you, fine. If no, and your acceptance angle is given to you, then you will take this formula or you will take this equation as finding your numerical aperture. If your critical angle is given, you will take this expression, okay, and directly if critical angle is given, you take it. Or if like theta, your refractive index indices, so your refractive indices of both the mediums are provided, then you take this. So if you have like two indices refractive index, then definitely you can just directly put over here itself, right? So this is just a form of writing this. So this is the three expressions that you have to keep in your mind. I'll be giving you problems, don't worry. The typical optical fiber communication occurs in this way. This is your transmitter part, this is your channel part, okay, and this is your receiver part. Your transmitter definitely has a driver circuit, won't it? Because any transmitting signal or any transmitter would definitely need a push up, okay, a voltage, a circuit which will actually drive it. So that's your driver circuit, which gives you the power and your what do you say, the threshold, okay. So you have a driver circuit, then you have an optical source, and that optical source can be either your LED or it can be your laser, okay. And then you have your optical fiber, that is your channel. Again, based on that, you have like two types of optical fibers. That is your, it can be either your step index or it can be your graded index. Again, you have like the subdivisions of them, okay. But whether it is a single, single mode or your multi-mode, okay. Then you have your receiver side, you have photodetector. This will be either your pin photodiode or your APD photodiode, okay. Then, okay, here there will be your conversion from your electrical to optical. So this part is nothing but your electrical to optical, since it is your optical form of signal that will transmit, and here it will be from your optical to electrical form, okay. But the signal which will be provided at the end of the photodetector, the strength of this signal will be less, okay. So in order to provide, see, I am an end user, you are an end user, so we need better things at the end, right? For example, like in your home, I know you all are at home, so you must have given good amount of instruction to your moms right now, or anyone who cooks at your home, or to your cook, you must have given some instruction to, prepare a good dish. So let's say your mom just comes over and gives you boiled potatoes. So what would you say? No, I don't want it. I don't want just boiled potatoes, but definitely the difference between your, it is same as your electrical spark and your light. Are your light and electrical spark the same thing? The light, that optical means what? Optical means your light form, right? It is nothing but your light that is traveling. That is your optical signal. So your electrical signal is your electrical, that you know, of course. But optical is nothing but light. See, when I say LED as form, your source, laser is a source. What comes from a LED or laser? Light. Okay, that's the reason why your optical fiber supports it. You need glass, isn't it, for the transmission? I hope I answered the question. See, if you have any doubt, please ask. So don't think that these are small doubts. No, actually, you may not understand. Thank you, Shams. Satya Sundar, sorry. So many people, they may not know few things. It's absolutely fine. And this class is to clear all of that. And I want you to get your fundamentals clear as much as possible, because many of the students, your seniors, and actually those who have done their masters and then later PhD, they are actually pursuing degree, your thesis in this one. Okay. APD is your avalanche photodiode. Really? Okay. We will discuss about this in details. Do not worry. But I just want you all to be aware about these terms. But do not bang your heads for remembering everything over here. This is the avalanche photodiode. Forget about it. This is just an introductory thing to it. We will discuss in details in your classes as we get along. Right. So I was talking about your cooking, right? So if your mom gives you boiled potatoes, I'm pretty sure you're not going to appreciate it. You will ask, like, make aloo dum for me, or make some other like curry for me, or like mashed potatoes. Do something about it. isn't it? You wouldn't appreciate your just boiled potatoes. In a similar manner, so you have a raw potato over here, you have a boiled potato over here. So this part of your receiver is very important, okay? Because it improves. Why there is no use of, oh dear Lord. Okay. So the if I got the question correct, why there is no use of mirror coating? Did you mean inside? Instead, you have, or instead, okay, mirror coating instead of cladding in the optical fiber. See, the mirror thing that actually is there. It's not like it's not there. It's there in your light source. Of course. How else do you expect it to reflect? It is there in your, so we will discuss that in your construction. In your construction of your LED and your laser, yes, there is mirror in it which helps in the reflection part. Even there are variety of mirrors, the types of mirrors based on the coatings which are used, etc., etc. So that all we will be covering in the structural analysis of LED and laser. Okay, I hope I am clear. Did you get it right, Sujit? Please type it. Yes. So these are the please go on, if you have doubts, you can write in your chat box. I think it's more better way to do it. Okay, because you might be feeling a little shy to speak or anything. Just write in the chat box. Don't worry. Even if I'm getting interrupted or somewhere, I'll read it at the last and I'll answer all the questions. Don't worry. Okay. So yes, I was telling you this is your dum aloo recipe that happens over here. Okay. So whatever signal you get over here has got a little less strength, which is emphasized more. Like you go to gyms, isn't it? You build up your strength, right? Build up your muscles, your bones. In a similar manner, you have an amplifier and a signal restorer that is used in order to get, try to, what do you say, restore a signal as much as possible by the device. And you have amplifier. Again, there are types of amplifiers. There's amplifier circuit, but we wouldn't be studying much on this part. There is another subject for that. So I guess the syllabus does not emphasize on this part. Okay. So after this, it goes to your end user, right? So this is your optical fiber communication. We have already, I haven't told you what is step index, what is grid index, what is single mode, what is multi mode. So I'll directly show over here. You will be able to understand. So the step index means it is nothing but your step index and grid index are actually based on your refractive index variation along core and cladding. So this is what decides structure to be fiber to be your step index or your grid index. Please keep in your mind the way the refractive index actually varies along the core and the cladding. So in core here, actually it is like this, like a stepping index form, like it rises and falls because your RI for your cladding is less, right? It is less for your cladding, then it increases throughout here, and then it's like this. Okay, actually it should be like this, but I have already written over here. So you can just imagine like, go ahead, or I'll do on this side. Okay, so that means like if this is whatever value, let's say it is your 0.1, it actually doesn't exist like this. I'm just telling you a random value. 2. So throughout the core, it will be 2 only. Any place throughout the core, it will be 2 only. And then let's say it is 0.1 or 1, whatever value it is. Okay. So it will be like this. But in case of the graded index fiber, see, it is written over here like this. But in case of your step index, it's like this. It is given like a this marking. In your step index, it is like this. It is uniform. Okay. So the difference being in your step index, your RI is uniform in the code. Okay. But in case of your graded index, the RI or the refractive index is highest along the central line of the code. At the center of the code, it gradually decreases when it reaches the cladding. Okay. So here it's maximum at the center and it decreases, it goes on decreasing towards the cladding. Similarly towards the clad. When I say towards the cladding, both the sides. See, it's actually not in this form. If you see, it's actually like a circular form, right? So you have a cylindrical slab, you have a what do you say? Your general slab also. What is the structure called as cylindrical and the what do you say? Like a rectangular slab. Okay, cylindrical slab and you have rectangular slab. So the reflection and the system will be different. Okay, the ones which we use are usually cylindrical slabs. Okay, so it is like this. Keep this structure also in mind. So this is the basic difference between just. I will not push you through this theory things. Okay, I am speaking. I am telling you something. Please listen to it carefully. Once you keep that in your mind, it will be easy for you as gradually we proceed through the subject. Do not keep everything like hard and like by hard it. Don't do it like that. Neither do I like it. I never want students to buy hard things. Understand it. Keep reading it again and again. Keep those things recalling in your ears. That is more than enough. Okay. So just keep the structure in your mind. That is your refractive index in case of your step index. It's uniform throughout your code. Here it is same, here it is same, here it is same, everywhere it is same. But in case of your grid index, here it is different, here it is different, here it is different. Everywhere it is like different. Here being the maximum, little less, least, less, least. Okay. So that is your step index and grid index. Then you have your single mode and multi-mode. Okay. So your single mode related to laser, multi-mode related to LED. And of course, multi-mode is much more preferred than your single mode. You will know why. So single mode means a single mode will just travel. Multi-mode means it will go on like reflecting, and like in multiple forms, it will reach the destination. So it will be like splitting, and then again it will be accumulated, and then it will be you'll be getting at the end of your receiver, right? And in case of your this is your multi-mode step index, this is your multi-mode graded index. So you can see in step index, it is like going in a one-shot form, but in case of your multi-mode graded index, it is going like a sinusoidal form. So remember, this line is this line, then this line, and this line, okay? So don't get confused like, what is happening here. So this line is your this line. So in this manner, it is actually happening. So it's like this. Okay. So don't get confused. So this one, so this. So I hope you're getting. So like this one is nothing but this one. Okay. Then this blue one is nothing but this one, the outer one. Understood? That is your difference between your multi-mode and your step multi-mode step index, multi-mode graded index. So the different type of dispersion, that is intermodal, intramodal, metal dispersion, etc. We will read all this in due course of time. So the basics of this have been taken from ma'am's book. Okay, the first one. And rest, of course, there is one more book which is a journal which was written by Patra sir. Okay, so I think this is Patra sir only. And this is another book that is from your Wiley book. So few of the other sources which are taken into account, and this file has been formed. Okay, so I hope we have come to the end of the first lecture. If you have any doubt, please write in the chat box. I'll take the questions. If not, then we'll just mark the attendance and we'll finish up the class. And next class, I wish you all to go through other laws of reflection, etc., etc. And we'll be beginning with the transmission of light through your step index fiber. Then, sorry, before that, we'll do some problems and then we'll discuss about what are different modes, and then we'll go with the step index and step index fiber. The first one is step index. We'll deal with that in the next class. So if you have any doubt, please write in the chat box. In the meanwhile, I'll mark the attendance.